Okay, here we have a word problem. Remember, with any word problem, what we want to do is read the question carefully and highlight any of the important information. So let's read it. I'll just read it out loud. A house contractor needs shingles to buy a new roof. He wants to hire a company that will give him the lowest price, of course. Two options are shown below. Everyday Roofing charges a base rate of $80, so that is some information that's important, plus $2 per shingle. Okay, and another company, Quality Concrete, charges a base rate of $60 plus $3 per shingle. So the question is, when would it be cheaper to use the first option? And another question, when would it be cheaper to use the second option? Okay, we're going to approach this problem using linear equations. Let's consider everyday roofing first. Everyday roofing. Okay, so we're going to let C be the cost of hiring the roofer, and we're going to let N be the number of shingles. Okay, and our total cost for hiring everyday roofing will be dependent on the number of shingles. So remember what we know about linear equations. The slope of a line is related to the rate of change, or the slope is it's the rate. It's how one quantity depends on another. And that's what we have here, what I circled in red, $2 per shingle. When you see that word per here, that's telling you that there is a rate happening, and it's probably going to be part of it's going to be the slope of a line. So, and that's exactly what we get. If it costs $2 per shingle and we use N number of shingles, remember N is just a variable, it takes on numerical values. This 2N is exactly how much we would pay for N shingles. But there's more. Just for everyday roofing showing up, even if they don't put in any shingles, they're going to charge us $80. So that comes from this base rate here. So we have this equation, which gives us the cost of hiring everyday roofing dependent on the number of shingles. All right, let's do Quality Concrete. Quality Concrete. Okay, we're going to use the same variables. We're going to still use cost for C and N for the number of shingles. And we can write a very similar equation for Quality Concrete. We have cost is, well, they have a different rate per shingle. Their rate is $3 per shingle. So it's a little bit more expensive per shingle, but their base rate over here is cheaper. It's only $60. So let's write that out, plus 60. Okay, so we have two equations. Let's highlight them. We have this one here for everyday roofing, and we have this one here for Quality Concrete. So now we can get to the questions. The first question, when would it be cheaper to use the first option? So before we answer that, what's good to know is, what is the boundary? What is the case where the two companies would charge us the most? Because if we go more shingles than that, one company will be cheaper, and if we go less shingles, the other company will be cheaper. So let's find the intersection, the N, which is in common to both of them, which gives us the same cost. And to do that, what I'm going to do is I'm going to find the intersection of these two lines. So this is something we talked about before. How do we find the intersection of lines? Well, where they intersect, the cost will be equal. So if the cost will be equal for both of them, that means that the right-hand side of these equations should be equal. So let's write that out. When they cost the same, we have 2n plus 80 is equal to 3n plus 60. So now if we look at this, this is an expression that just has one variable n, so we can solve for it. We'll bring everything that involves n onto one side and everything else onto the other. So we'll keep the 2n where it is, but we'll move that 3n to the left side. And when we do that, it changes from positive to negative. And when we do the same thing for the plus 80, we move it to the other side. It becomes minus 80 plus 60. And now we can group like terms. On the left, we have 2n minus 3n. We add their coefficients, and that gives us minus n. And on the right side, we get negative 20. And finally, we multiply both sides by minus 1, and we get n equals 20. So at 20 shingles, one of them is going to be cheaper than the other. And which would be the case in that? Which would be the case then? Well, we could test it. Let's say when n equals 10. When n equals 10, everyday roofing will cost 2 times 10 plus 80, which is equal to 100. And quality concrete will cost 3 times 10 plus 90, and that only, not 90, what am I thinking, plus 60, and that's just going to equal 90. I was getting ahead of myself there. So when n is less than 20 shingles, we want to use quality concrete because they're cheaper. So when n is less than 20 shingles, we want a higher quality concrete. And when n is greater than 20, everyday roofing will be cheaper. Okay, so that's how we solve this word problem using linear equations. I hope this video was helpful.